good evening, wherever it might be. My name is Sean, and I'm delighted you're joining us for today's ESPC community webinar. Today I'm joined by Pierre, who will cover Get Good, best practice for CI/CD and collaboration with Microsoft Fabric. We love hearing what you guys have to say, so remember to join the conversation about today's webinar and more on X. Our handle is at ESPC_community, and our hashtag is hashtag ESPC25. Tweet us, tag us, and tell us what you learned. Don't forget to check out our Learning Hub, which is they update the latest blogs, ebooks, webinars, and how-to videos. You can access and view the Learning Hub by visiting our website, sharepointeurope.com, and clicking Content tab at the top. Don't let the learning stop here. Continue to keep up and stay ahead by joining us for our next webinar, Semantic Model Optimization by Enterprise AI Enablement with Samson Truong. This webinar will take place Thursday, November 20th at 4 p.m. CET. For more information on this webinar, please check out www.sharepointeurope.com/register for webinars. European Microsoft Fabric Community Conference 2026, hashtag FabCon Europe, is on the 20th of September to the 1st October 2026 in Barcelona, Spain. Join Europe's largest Microsoft Tech conference focused on Microsoft Fabric, brought to you in partnership with Microsoft by the team behind the ESPC and European Power Platform Conference. Building on 130 plus expert-led sessions at FabCon Europe 25, the 2006 edition will help you modernize your data platform with data engineering, governance and Fabric, analytics and BI with Power BI and Fabric, AI integration with Azure AI and Copilot, end-to-end Microsoft Cloud scenarios. Hear from Microsoft product teams, MVPs, and community leaders through keynotes, deep dive tutorials, and in-depth sessions. Shape the future of data at FabCon Europe 2026. After the webinar, we'll have a questions and answers session. Type any questions you might have into the chat box. Questions will be selected and answered at the end of the presentation. This webinar will be recorded and added to the Resource Center, where you'll be notified by email when it's available. And now I'm going to pass you over to today's webinar presenter, Pierre. Hello, Pierre. Thanks for joining us today.
Hey, and thanks for letting me on. Really excited to kind of like do a rerun of my session from FabCon in Vienna. So that's also why I kind of like I kept the FabCon slides, but added the rerun as a subtitle to today's session. So just kind of like a few introduction lines first. My name is Per. I am currently a technical architect and community ambassador at Tabular Editor, but we've been working with data and data platforms for the last 15, 16 years or so. I have a developer background, so that's also why I'm kind of like very much into doing automation. I tend to see myself as a lazy developer. I don't want to do things or the same thing twice or multiple times. So I try to kind of like keep automation in mind in everything that I do. So this is something that is really near and dear to my heart. You will also find all the samples that I'm going to show you today, as well as the presentation from today. You will find that on my GitHub site. Use the QR code. I will also put it in the chat later on as well. And also jump to my blog site for additional articles and blog posts on automation and so on and so forth. Also, do connect with me on LinkedIn if you are not already. I do see some familiar faces among the audience, so but there might be a few who don't know me. So please connect. I'll be happy to. So today's session is on Git and CI/CD best practices. We will not dig into anything like the different Git commands, so stashing and committing and all that stuff. We will kind of like keep a focus on the Fabric side of things, and I'll explain to you what my go-tos are in regards to best practice, how I do the orchestration of my workspaces, my repos, and so on and so forth, and also how I kind of like work with my feature development, how I do the whole kind of like CI/CD, so promoting things from a development environment into a test environment and further on into production. That is what we're going to cover today. And as I said, please go ahead and visit my GitHub site, where you will find all the demos also shown in today's session. So back to the agenda, where we're going today and what we'll cover. As I said, I've been kind of like working with data and AI for the past 15, 16 years. And I also work with Fabric across several projects. I was a part of the Project Trident preview back in 2022. So I have had my share of kind of like learnings, mistakes, or had to adapt constantly in regards to making sure that whatever I did was also kind of like robust and scalable in the long end. So during this session today, I'll try to kind of like walk you through my recommendations and best practices on some of these learnings. And I also want to take you through kind of like a natural path from zero to hero. So we're going to start with designing the architecture. So how does my kind of like go-to starting point architecture look like? So what is the foundation for moving forward? We'll jump into workspaces, repos, environments. So how many environments do we want to kind of like cater for? Is that a dev test production environment, or do we need a pre-prod for that as well? How will I structure my repo? Is it multiple repos, a single repo? And also the workspaces. Is it a monolith, or again, am I going to divide kind of like my workloads into multiple workspaces? And once we're done with that, we'll look into the whole Git integration, the different branching strategies, of ways of working, and then we'll dig into automation and CI/CD. Automation will actually be kind of like covered throughout the whole agenda. So we will also talk about automation when we set up our Fabric environments, as well as when we do deployment and so on and so forth. But we'll kind of like also dig a little bit deeper into automation and what the tool sets are for us to use in Fabric. And then finally, some kind of like summing up tips and tricks, and hopefully you will also have questions, which I'll then try to answer at the end of today's session. So a lot of things to cover. So we also need to get going. This is kind of like what we will cover today. So we'll cover the architecture and platform design, branching strategies, and so on and so forth. We'll also touch upon the Fabric CLI, so the command line interface for Fabric, as well as the Fabric CICD, which is an open source library. I'll also cover that. But there's a lot of things that we will not cover, and which I cannot cover in this session. So it's kind of like out of scope. So that is more in regards to how do we develop our data pipelines and notebooks and so on and so forth. I won't be touching upon the Terraform provider, not talk so much about REST APIs and so on and so forth. So that will kind of like be something for another session later on. So let's get good, as I state or call my session. So let's first draw attention to why it is so important to kind of like cater for CI/CD and why Git matters. Of course, there's always the kind of like classic foundations why we use Git and why we use CI/CD and source control. So the classic foundation is, of course, we need to have a version control of everything that we do, so we can track changes and so on and so forth. We can roll back if we implement something that isn't working. We can do reviews and testing and so on and so forth, and of course collaboration, so we can work together in multiple teams, multiple developers on different part of our code, maybe co-building stuffs like semantic models, notebooks for doing our data preparation and transformation and so on and so forth. But when it comes to Fabric, there's also kind of like a different angle to it. You will also see when we get to the demo that everything in Fabric, when you do Git integration, is kind of like stored declarative. So you have all your notebooks and pipelines and so on in a kind of like code base. So your data pipelines is in JSON, your notebooks is in Python files and so on and so forth. So that also makes it a lot more easier to navigate from a Fabric angle. Everything is also, all items are then mapped to Git folders, which you will also see in the Git repo when we jump to that. Then we can use different purpose-built tools for doing our automation. I mentioned some of them. One of them is the Fabric CLI. Another one is the Fabric CICD Python library as well. And then, of course, kind of like, again, cater for the whole collaboration, doing collaboration at scale. Now let's jump to the architecture. So first, I kind of like want to establish a real-world foundation for the scope and the demos of this session. And in order to do so, I'll use my reference architecture as a starting point. This architecture consists of multiple layers, and I'll just kind of like go through them now. So you will also see that these different layers actually also corresponds to the different workload areas that we have in Fabric. So first of all, we have our data sources. That is typical. So when we work with a data platform, you have different sources. That could be business applications, APIs, on-prem SQL servers, Oracle servers, so on and so forth. It could also be event-driven sources like Event Hub or whatever. Then we do some ingest from those sources. My go-to is always the Data Factory data pipelines and the data engineering, so notebooks for doing data ingestion from APIs. And if we have more relational sources, I tend to use data pipelines for that. We, of course, move data into our OneLake. I will also touch upon the different layers of OneLake. So landing, base, and curated, a classic medallion architecture. Naming wise, you could call it layer ABC, doesn't matter, as long as kind of like the purpose of each of these layers are well defined. So the landing layer, shortly, landing layer is raw, untouched data. We have a lot of duplicates because if we do full load of a single table every day, then when we have passed 1 year, we will have more than 300 kind of like files of that specific data dump. So it's more to seen as a technical layer. Then we move data into our base layer. That's a silver layer. So this is where we do data duplication. We can add kind of like a functional history, like slowly changing dimension type 2 and so on, so forth to our data. We can manipulate column headers and so on, do simple translations, but not do any business logic yet. And then we have the curated layer, which is the gold layer, where we do our semantic modeling, our data products, and so on and so forth. And you could, of course, also include a rich layer or kind of like a layer in between the base and the curated. That's kind of like up for grab. For data preparation, so moving data between the different layers, data engineering is your go-to guy. So notebooks for kind of like mass processing those data. So moving data from landing to base and base to curated. So that also said, we have multiple notebooks, one notebook for each dimension, for example, one notebook for each fact transformation, and so on and so forth. Of course, Power BI for building our semantic model or hosting our semantic model. Power BI reports in order to present the data. And in regards to orchestrating, so kind of like where do we put our triggers on, where do we put our schedules on, where we need to do a daily or intraday loads of kind of like the whole value chain, then that is in Data Factory data pipelines. Like for us who used to or still working with Azure Data Factory, we would also kind of like build controller pipelines or master pipelines, which kind of like orchestrate the whole flow and then put triggers on that. And the same thing in Fabric. And then in order to support the kind of like this standard or starting point architecture, I want to introduce kind of like this core layer. So core is a layer where we can have different artifacts or items that kind of like cover the whole architecture. This could be a metadata store in either Fabric SQL database or in JSON files or whatever. It could also include environments which can go cross workspace and so on and so forth. There are different possibilities for storing data in the or storing items in the core layer. And I am a tablet editor guy, so of course I also use tablet editor for my semantic modeling. No doubt about that. So this was a little bit about kind of like how does the architecture and how do we want to design the architecture? How will that then correspond to the way that we structure our workspaces in order to kind of like align with the architecture that I just showed you? So of course, I tend to say, of course, we will use a multi-workspace approach. So the same way as you saw with the workspaces, with the architecture, that we have different layers. So we have a store layer where we kind of like store all our data. We have an ingest layer, we have a preparation layer, orchestrate layer, model layer, present layer, and so on and so forth. We will do the same thing in regards to the workspaces. So we'll separate all of these different layers of our architecture into corresponding workspaces. So we'll have a store workspace, core workspace, ingest, prepare, model, present, and then orchestrate. And kind of like these different workspaces tend to fulfill a specific purpose or requirement. So in the core, as I said, we could have our metadatabases like SQL databases or Fabric CLI databases, environments, variable libraries, functions, and so on and so forth. Something that we can reuse across our workspaces. And then ingest is, as I said, data factory pipelines and notebooks. And prepare is notebooks, semantic models in our model layer. And then in the present layer, you could also call this visualization or whatever, or insights maybe. That is where we put our reports, our dashboards, our organizational apps, and so on and so forth. And then we have orchestration in a separate orchestration workspace. And back to those environments, I always go with a 3-tier kind of like starting point. So I will have all these workspaces in a development, in a test, and in a production version. So of course, if you look at the number of workspaces multiplied with the number of environments, this will give you, in a classic standard approach, starting point architecture, that will give you 21 workspaces. And some might say, hey, that's a lot, but there's actually kind of like there's a method to the madness from my point of view, and also working with multiple Fabric solution and Fabric projects. I've seen that kind of like separating this gives us a whole lot of benefits. There are multiple benefits into that. So one of them is security and access control. Let's say you have a data ingestion department, which should not have access to any of the reports, semantic models. They shouldn't touch anything in regards to the notebooks and so on and so forth. They just need to work on their ingesting pipelines. Then, of course, you can separate. So separation of duties, so that the ingesting team can only work with your data pipelines. And again, your business analysts doing the semantic models, they only have access to the modeling and the kind of like the data presentation layer of things. So separation of duty, kind of like a really clear benefit of doing those workspace separations. Then there's network and connectivity. What just went into GA in October, release of Fabric, was that we now have private link on workspace level. So there's also managed private endpoints as well, which is also on workspace level. So that is a way to kind of like not go with a one size fits all, but we need to maybe assign specific access control to a or network control to a specific workspace. That is something that is also much more feasible if we separate those workspaces. Capacity isolation, also a benefit. So let's say you have 3 different Fabric capacities. You use one of the capacities for your data ingestion, one of the capacities for your data preparation, and then you use a third capacity for your data modeling and serving of those data in your Power BI reports. Maybe you only have 2 where you kind of like do a back-end capacity and a front-end capacity. But anyway, you have the possibility to mix those capacities. Also in regards to environments, so having at test capacity, at development capacity, at production capacity. So separating workspaces also enables you to separate the workload and assign it to specific capacities for that matter. Governance and compliance, so domains and so on and so forth, is also a critical part. Testing and deploying, item organization, such a simple thing as kind of like keeping it tight and needy in your workspaces. I know we do have folders in workspaces now, and I'll also show you that. But those workspaces kind of like tend to grow if we need to keep both notebooks and data pipelines and semantic models and functions and everything inside a kind of like a monolith of a workspace. So a lot of kind of like different good explanations or benefits of separating it. And also Git integration as well. So kind of like isolating the footprint that we do when we work. And I'll also get back to that point. So let's kind of like focus a little bit more on the Git integration in Microsoft Fabric, because many of you, I think maybe most of you probably have your workspaces integrated into Git, but in order for everyone to be kind of like aligned, let's just quickly jump back and look at how the Git integration in Microsoft Fabric works. So Git integration is based on workspace level. So it's on a workspace level that you do the Git integration. That's also why I would encourage you to kind of like separate things. So you connect a single workspace to a Git repo, and a single workspace is assigned to a single branch. You can, of course, switch that, but that will also switch everything inside that specific workspace. There is support for both Azure DevOps repos, as well as GitHub and GitHub Enterprise repos. As for GitHub, it is cloud only. Then it has kind of like a bi-directional synchronization. So if I do something in my Fabric workspace, I will need to push that into my repo. If I do something locally or do something inside my repo, so kind of like outside of the Fabric or Power BI UI or service, I would need to pull that into my workspace in order for it to take effect. And then it has kind of like native support for, I say most of the items. There are a few items that aren't supported, dashboards, for example, which will also never ever be supported. From my point of view, I think the dashboards are legacy. So, and some of these kind of like items are currently only supported in preview. And then for all of the kind of like Git integration operations, so connecting a workspace to a Git repo, doing the synchronization, committing stuff, and so on and so forth. That is also possible using APIs, and that is also what I'll be doing in some of the kind of like ways of working that I'll demonstrate later on. So I'll utilize some of these Fabric REST APIs for supporting my ways of working. And then in regards to authentication, this is also where something or a lot have happened right up until FabCon in Vienna. There was not support for service principal when using Azure DevOps, or it was supported. Then Microsoft pulled back a bit again because there were issues, and then they released it just prior to FabCon in Vienna. But we do have full support now. I know it says only partly supported. It is fully supported now in regards to using service principals as kind of like connecting your workspaces to a specific repo and branch. And I'll also show you that. Now, jumping back, so that said, there are also kind of like a lot of different options to choose from when you define your repo and your Fabric integration. And this is kind of like my go-to. Take it or leave it as it is. This is based on my experience. So I always use a mono repo. And when I say mono repo, I use just a single repository. But that single repository is then orchestrated into different folders. Remember I said that we have these 7 different workspace layers or architectural layers in our starting point architecture, I'll actually create or I have a folder for each of these layers in my repository. So for everything that goes into the prepare workspace, that will be in a prepare folder. Everything that is has to do with semantic models, that will be in my model folder. But I use a single repo. I actually started out by using multiple repos. But when you work with data platforms where you do need to do some data ingestion, you need to do some data preparation, and then you need to kind of like get some data into your model, that would require a lot of different branches, and things weren't kind of like stitched together. So it was kind of like different silos of development. And then where did the documentation need to go? Would that go into a separate repo? So I also have a repo folder for documentation. As I said, I organize the workspaces by layer. I use a clear name convention. You will also see that when we jump into demo in a few minutes. And then you can pretty much use the Git provider of your choice. I will show you both Azure DevOps and GitHub in the demos, kind of like switching back and forth between those two. And then branching strategy, we'll save that for a little bit later in the session. But there's no one size fits all. It depends on the size of your solution. It depends on the complexity, the size of your team. If you're a single developer, if you're working in kind of like a more global setup with multiple developers, maybe across teams. Good. And then Git integration on all development workspaces by default. My approach is not to Git connect your workspaces in test and production. I will get back to that when we talk about deployment. And then you can also see all of these different workspaces are Git integrated, so pretty neat. The GitHub repo, as I said, I have a standard way of doing things. So I have my Azure pipeline, so that is my Azure DevOps specific pipelines for doing deployment, setting up environments, setting up feature branches, so on. They live inside the Azure pipelines. GitHub live inside the GitHub, so that is GitHub Actions and workflows. Automation is for storing automating scripts. That could be Python files, resource files, and so on and so forth that I use to kind of like set it up. Documentation inside a documentation folder. And then we have this solution folder, as I said, where I have these different folders, core, ingest, model, orchestrate, and so on and so forth, all of which are kind of like assigned to these different layers of our architecture. So this guy says, hey, how do I get this done? There's a lot of things to set up. There's a lot of Git integration to be done. Maybe I need to create specific workspace identities when I set up my workspaces. Maybe I need to do specific network settings and so on and so forth. So let me introduce you to something that you will also find in the repo that I have on GitHub. It's kind of like a recipe-based approach. You could, for that matter, also use Terraform for the same purpose. I started out by kind of like implementing my own first based on the Fabric REST APIs. So did a hell of a lot of Python functions and so on and so forth in order to utilize the Fabric REST APIs to set up workspaces, assign permissions, and so on and so forth, assign a capacity. Then came the Fabric CLI. So everything is actually based on the Fabric CLI where it is possible. If the Fabric CLI doesn't have commands for some of the things that I do, I still use the Fabric CLI, but I use a command within the Fabric CLI called API, which can then be used to execute some of the Fabric APIs and Power BI APIs, which are currently not available as standalone commands. The recipe approach is based on JSON, so you could see it as the same with a bicep YAML file or as a Terraform file. So JSON, simple JSON file, which kind of like it defines the architecture that I want to build. Then it utilizes Python and the Fabric CLI to set up these different workspaces, and assign them to a repo and so on and so forth. They can run from both DevOps and GitHub, as well as on your local machine. There are also Python files that so you can kind of like simulate the exact same on your local machine. You don't have to use DevOps or GitHub. And then there's a simple requirement. You need a service principal, and of course, you need a Fabric capacity. The Fabric capacity could be a trial. It could be a paid capacity. It really doesn't matter. So let's jump into a short demo. So what I first want to show you is a local setup. As you can see, I have my folders, and in the automation folder, I have defined different kind of like environments. There's an infrastructure file which contains how is the kind of like base setup of my solution. So I give it a naming convention. I have some merge fields like put in layers, and then my environment should be in square brackets. This is where we get down to some of those critical things in regards to naming convention. I define a name of the capacity to be used. In my solution, the capacity could also be put on the layers as well. So it doesn't have to be kind of like a global capacity. In this case, I'll just use the same capacity for all of my workspaces. I define a administrative group that needs to be assigned when I do it. I also define that I would like to set up some kind of like generic Fabric connections, one for the pipelines and one for databases. They will be set up with Service Principal. And then I defined all the layers that I need. So I need a core layer. In this layer, I would like a SQL database. What should the name of that SQL database be? Also, I would like a lakehouse connection created. I would like an orchestration workspace. For that matter, in that case, I would also like it to create a workspace identity, prepare, model, and so on and so forth. That is the basic. And then each individual environment file contains information in regards to, for example, how should it be connected to Git, which folder should it point to, what are the Git credentials needs to be used, and so on and so forth. If you jump to the production file, you will see that we create lake houses like landing, base, and curated. We'll create a metadatabase, and we'll create other layers without any artifacts at all. So this is kind of like a simple recipe approach in regards to setting up the environment. And then inside the scripts file of script folder of the repo, you will find different Python scripts that will then read and use those recipe files to create the environments. What I did on the kind of like my Windows machine using Azure DevOps was I ran it locally. So you can actually see by running my my local setup script, it configures first some generic connections like a data pipeline, a database connection. It also creates a connection to my Azure DevOps repo using a service principal. It assigns permissions so that it is not only the service principal who have access to those connections, it is also me or the admin group that I put on. Then it creates some workspaces, assigns workspace permissions, set up Git integration, so on and so forth. Then it continues doing the same thing for testing. And as you can see in testing, it actually creates items. Those items are not created in development because they are part of my solution template. So if we jump down to store, you will see that they have a base created and a landing lakehouse. They are just empty. They are just kind of like just a shell. But so we don't create those automatically. Those will be created when we merge or kind of like pull in that specific repo using the Git integration. And production as well. So we create different, that's a little bit of big out in regards to the output here. That's wrong, but it creates a landing base and it created and does all the things that needs to be done in regards to setting up my environment. And if we then jump to Fabric, do a refresh, you will see that we have all these peer insights, different workspaces, so on and so forth. And you can also see that if I jump to the prepare, for example, you can see that it's been connected to my Git repo. I didn't do anything. This is completely done by the setup process. And you will see that it completely corresponds to the prepare part of things that I have in my prepare. So a folder base to created, which contains controllers, dimensions, and facts, landing to base, setup, and so on and so forth. You will see that that is the exact same structure that I have in inside my prepare workspace. And also, if we jump to the storage side of things, you'll see that it has also created those base and created and landing lakehouses based on the fact that these items are also in my repo. So I have kind of like this template of a repo that can be used in order to set up these things. Now jumping to another solution. This is running on GitHub. So as you can see, we can also just run everything through a simple setup procedure. So I have a Fabric solution setup action inside GitHub. Running that will actually just create all of the different. This one is a different naming. So it will create an ESPC data pipeline connection, SQL connection. It will create the different development workspaces that are needed. This one is a more simple solution. So I just have core, store, orchestrate, ingest, and prepare. There's no modeling or reports inside this solution. That's just something that are kind of like defined in the recipe files. And it does the same thing for test and for production. So within a matter of minutes, using this approach, kind of like a recipe approach, we can easily set up our environments and actually also tear them down again. And it's independent. So if I run the same pipeline multiple times and there's no changes, nothing will be done. But if I do some changes inside my recipe files, those changes will be applied. Good. And as you can see, if I jump to my workspaces and do a refresh, you will see that those ESPC folders are now also present. And again, jumping to prepare, you'll see that it has been connected to my source control, and everything is kind of like up and running by default, just running this pipeline, which I ran just prior to this session. As you can see, it ran an hour ago, and within 6 minutes, it set up the complete kind of like infrastructure, all 21 workspaces, did the whole part in regards to setting authentication, so on and so forth. So let's jump back to the slide deck and talk a little bit about branching strategies. So my kind of like go-to is kind of like just a simple approach. So if you are working in an environment, or if you're working in an organization where you're the only one or you're just a few, keep it simple. Keep it very simple with a single main branch where you kind of like base all of your development upon. And then whenever you need to do a feature, you can branch out and then work on that specific feature before moving it back into your main branch and then deploying it later on. So talking a little bit about development ways of working and the development cycle. So what I've done also in the repo that you can download is created an automated process for also creating the workspaces that are needed to do a feature development. For those of you who have been working with feature development inside Fabric, know that from the Fabric UI, you can kind of like branch out and create a new workspace directly from within the UI. So what it does is it automatically creates a new branch for you. It also creates a workspace and assigns that branch to the specific workspace. So fine, that's completely fine, but it has kind of like limitations. Let's say you want to work on a different capacity. So every time you do a feature development, you want to work on a development capacity. Maybe it's your personal capacity, something like that. That is not feasible. It will always create those feature workspaces based on the capacity of kind of like the source workspace. Also, if you need to change anything in regards to authorization, so permissions on those workspaces, if you need to change Spark settings, which is extremely important when working multiple developers in Fabric, because you will pretty easily and pretty fast run into issues in regards to throttling and kind of like using the limits that you have in regards to how many sessions you can start up. Maybe you want to do something in regards to setting up managed private endpoints and so on and so forth on those workspaces. That is not something that will be done if you use the UI in Fabric for creating your feature workspaces. So what I've done is I created a simple pipeline and a simple Python script, which will trigger whenever you create a specific or a feature based on a specific naming convention. So the naming convention I use when I create a new feature. So let's say I want to build something on my semantic model. I call my feature / and then the name of the feature. This will trigger the pipeline that will then create the corresponding workspaces needed to implement that specific feature. Once that specific feature is done and I create a pull request in order to merge it into main, once that pull request is approved, another pipeline triggers, which will then tear down my development workspaces again, so that we are kind of like on a clean slate. So we don't have these orphanage or stale workspaces floating around and kind of like taking up space on our workspace list. So let's quickly jump to a demo on that. Why automate? I already mentioned it. Doing the ClickOps thing in Fabric manually process, we can fully automate it. It is single workspace if you do it in Fabric, so you cannot say, I want to branch out to a new feature branch, create multiple workspaces. It'll just be kind of like one single workspace that will be created. Maybe we want to create a feature branch which creates 3 different feature workspaces for prepare, ingest, and model maybe. And then again, we can customize everything in regards to access control list, Spark settings, workspace identity, capacity, and so on and so forth. And we can support kind of like automated synchronization and cleanup of the things that we do. So let's quickly jump to a demo of that. So I am currently in my Azure DevOps environment. I will go to branches. You'll see I don't have any branches right now apart from my main branch. So what I'll do is I'll create a new feature branch and call that my new feature, whatever, create. So as you can see, this new feature is kind of like just a clone. It's a copy of my main repo. So this is where I have my solution with the different layers and so on and so forth. As I said, I've created a pipeline that will trigger whenever I create something called feature / inside this pipeline. We will, when it starts running, we will set up those feature development workspaces that are needed in order to kind of like do the actual implementation. If you were quick when we navigated the repo, you saw that apart from the different environments, there's also a feature JSON recipe file. This feature JSON recipe file actually defines how things are to be set up when creating new features. It's very simple. We define a naming convention. I like to put an asterisk in front because then all my feature branches go on top. We define a capacity, the Git settings that needs to be done, permissions need to be assigned, and then the layers that we need to create. And of course, since we're working with scripts and everything in the automation world, we could say, okay, if you create your feature branch and call it something with all, or if you only call it prepare, then we should only create a prepare workspace and so on and so forth. But in this case, what I've done is I've said, okay, whenever I create a new feature, it should create a prepare workspace and it should create a model workspace, and it should assign the model workspace to the solution model folder of my repo and the prepare folder for the prepare workspace. So jumping back, you'll see that it took 1 minute. It created 2 new workspaces, assigned the permissions, and it set up Git integration. And as you can see, it also did something with the Spark settings on the prepare workspace. Now jumping back, you can see that I put in some Spark settings in order for all my development feature workspaces to kind of like run on single node. That way, it enables us to work multiple users inside that specific kind of like environment without stepping over each other's feet. And if we jump back to Fabric, you will now see that under workspaces, probably need to refresh again. We have the model and we have the prepare set up for us to start working. And let's just quickly jump back, because what I want to show you is the fact that if I jump to, let me just do a quick fetch and then jump to this new feature, my new feature. That should be it right here. So I'm switching to my new feature, the new feature that we just created. Because what I want to do is I want to manipulate a little bit with my semantic model. So opening up Tabular Editor, for those of you who worked with semantic models, you do know that we got the UDFs just before FabCon. So these kind of like user-defined functions that are kind of like a encapsulated logic that we can reuse across our semantic model and multiple models. So what they do is they kind of like work the same way as if you had a stored procedure that you would call every time you needed to multiply 2 figures or something like that, or two numbers. We can then reuse these functions across our model. Don't have to kind of like reproduce the same DAX functionality all the time. So I open up my model. And what I just need to do in order for the functions to work is I need to change it to compatibility level. And where is the, that was strange. Okay, very strange. Okay, there it was. So we have the functions now. So let's create a new function. New user-defined function. We'll give it a name. And that wasn't part of the plan. I will instead just quickly jump. Then we'll just take all good. And then what I will do is inside my model, I have a lot of different comparison to relative to target comparison. So a lot of things where I actually do the same thing. This is a good way to kind of like use those user-defined functions. So if I jump back to my relative to target, you will see that it takes in an actual and then takes in target. So what I'll do is I'll quickly just create a new C# script, run the script, and then there was a mistake. Cool. Anyway, won't spend time on that one. It has to do with this. It has to do with the .NET version. But anyway, let's see. I changed something in my model, and as you can see, there are changes to my model. What I'll do now is I will update this one, and then push it to Azure DevOps. So I've created made some local changes outside of my Fabric environment. I'm pushing that into my workspace. Now, what will also happen is that if I jump to my pipelines again, you will see that it actually runs this create feature workspace again. But this time it will identify, hey, my feature workspace already exists, so I won't recreate it. But due to the fact that there was a setting in my feature that says git synchronization on commit, what I've done is I've made some logic that will actually make sure that those changes that I applied to my Git repo will automatically be synchronized back. And as you can see, it already exists. I won't create this feature workspace. Instead, I'll synchronize the workspace so that it kind of like gets updated with the latest changes that I did. So you don't have to jump into Fabric, click on synchronization and update for that matter. Also kind of like a way to remove the risk of doing mistakes and so on. It can be error prone if you need to remember all the different tasks that you need to do when you work outside in order to update your feature workspaces and so on and so forth. Good. Now we've done that, we can jump back to the branches. We can create a new pull request based on this one. I know I'm not complying with the normal standards in regards to review, because what I'll do is I'll approve my own pull requests just for the sake of the demo. So what will happen now is it will take all the changes I did inside my feature development and push that into the main branch so that it is kind of like ready to be deployed to test and then further on to production once it has been approved. Now, what will happen now is inside the pipelines, you will see when it gets to load that it actually triggers a cleanup feature workspace. This is because there's a trigger that whenever a pull request is completed and something is merged into main, it will trigger this cleanup workspace. What it will do is it will identify what is the source branch that I pushed into my main branch, and then it will delete those associated workspaces so that we are completely kind of like have a clean slate inside our Fabric environment, so we don't have all these feature workspaces floating around that has no use anymore. And as you can see, it deleted my old workspaces. Jumping back, these workspaces should now have been gone, and they're gone. So we are kind of like back on track, ready to move to deployment. Which takes me to my last bit on. Let's just find the slide deck. Just a second. There we go. So automation and CI/CD. So how do we get things deployed? Well, we have a lot of different options. We have the Fabric deployment pipelines, which is just kind of like a no-code, low-code. It is no-code, and it's, from my point of view, for the kind of like the more simpler solutions, because there's a lot of things you cannot do in regards to scalability and flexibility for that matter. So with the deployment Fabric deployment pipelines, you don't have the possibility to do these pre and post deployment operations. Let's say you want to load a SQL table, or maybe you want to process specific or refresh specific partitions of your semantic model. That is not something we can do. Also in regards to test and validation, it's kind of like very limited. Then you have something called Git-based deployments. This is actually where you assign your development to a development branch, your test environment or workspace to a test branch, and then production to a production branch or main branch or whatever you call it. And then you simply just kind of like merge your features into those specific branches that you need to deploy. This requires kind of like that you really stick to a process, because of the fact that it will require post-deployment and post-deployment operations, because you all know that if you move a pipeline that has that kind of like has a relationship to a notebook in a workspace, if you move that to a different workspace, it will still point to that old workspace. And when you move something from development into test, you of course need to also kind of like fix those relationships so that your test orchestration pipelines don't point to development notebooks and development ingestion pipelines. It needs to point to test, and the same way with production. So it requires a lot of kind of like manual approach afterwards in order to do that. My go-to is Git-based deployment using build environments. And I'll also shortly show you that we have maybe a few minutes left in regards to that. So I'll quickly show you how I do that. So the building blocks for this is the fundamentals of the Fabric CLI, and then also using the Fabric CI/CD Python library. So you saw that the whole kind of like process of setting things up, that was through the Fabric CLI. In regards to deployment of the solution, once it has been set up, once the infrastructure is in place, I personally prefer to use the Fabric CI/CD, which is an open source library developed by Microsoft, and they also use it internally at their own data platform team, supporting Arun with his figures. So it has this code first approach. So you don't need to kind of like interact with the Fabric APIs directly. It takes care of that. The really cool thing is it supports parameterization. It also supports dynamic parameterization, so that switching out workspace reference IDs and item IDs and so on can be done completely dynamically and automated within that specific deployment process. And then it supports pretty much all items. So all items with public APIs are currently supported. It also supports items that are only in preview. So you have a lot of much more flexibility in regards to deploying your items, whereas the Fabric deployment pipelines only support a subset of the items. This one supports everything, also the things that are currently in public preview. And then it also supports the unpublished. So if you delete something from your repo, let's say you delete a pipeline and you deploy from development to test, if that pipeline exists in test, it will remove it. So it also has the possibility, which is a feature, that it can kind of like auto unpublish those alternate items. Okay, time is running fast. I will probably not show you the live demo. Instead, I'll just go through some different scenarios in regards to doing the release. So a very simple approach is to have your feature branches and then your main branch. And then whenever you need to deploy something to test, you create a release branch. There will be a trigger on that release branch name. So if you call anything with release / and then give it a date or a release version or something like that, it will just kind of like create a copy of your main branch, and then it will trigger a deployment pipeline that will deploy that specific release branch to test. And then whenever you are ready, you can approve, and then it will also move the same deployment to production. Again, using the Fabric CI/CD library, so it will take care of those IDs that needs to be switched and so on and so forth, so that development points to development, test points to test, and production points to production. This is very suitable for small solutions, but not for large solution where you need to cover multiple domains, because this is all or nothing. Whenever we need to deploy something to production, it has to be the things that are in test. We cannot kind of like select bits and pieces or only take this feature and so on and so forth. So it's an all or nothing approach. If something is in main, it will go into test, and it will then be promoted to development. So There's a little bit of a lag on, let me see again. That was the scenario 1. There should be a scenario 2. No, something went wrong. But anyway, if I quickly... They were just parked below. The second scenario is the possibility for you to use an approach that Jacob Knightley from Microsoft also used. He's actually the founder and author behind the Fabric CLI, where they use cherry picking for picking specific features. Whenever they need to go into production, they cherry pick those features and move them into main. But their kind of like main collaboration branch will be test. There's an article in the link as well, as you can read. And the last one, which I also demoed during FabCon, I won't be able to do that due to the kind of like limited time, but is something called Octopus Merge. It is also part of the repo that you can download. So there is scripts and pipelines for demonstrating and showing you the Octopus Merge. What the Octopus Merge will do is it will, whenever you do some features and you create a pull request for that specific feature, it will never ever be merged into main before it is fully approved. But so when you need to deploy to test, you run a specific pipeline that only has the purpose to deploy to test. That pipeline will take the main branch, so that is what is currently in production. Then it will apply all the different features that has pending pull requests, create a new kind of like branch, and deploy that to test. Whenever something is approved and you say, okay, feature, we have 10 features, I need to approve feature number 1 and 10. You approve those features, they are merged into main. When you then need to deploy to production, you just deploy from main, because main already contains what is in production now, plus feature 1 and feature 10. And then when you deploy to test, it will take whatever is in main, including feature 1 and 10, and all the features in the middle will also be deployed to test. Octopus Merge, really nice alternative. It's not kind of like the new kid in school. It's has a few years on its back, but something that will definitely be suitable for larger teams. Also working with features and many features in parallel. Let's say you have a finance department and a HR department, which have different cycles in regards to when they can test and approve. And you still need to kind of like cater for a monolith solution where everything is in the same repo. That will be something that can be supported both through the scenario 3 and scenario 2. So summing up before taking questions, just kind of like highlighting what I went through. My approach is to split the workspaces and layers across the multiple workspaces. So use a mono repo as a starting point. Do leverage these kind of like purpose-built tools like the Fabric CLI, the REST APIs, or Terraform for doing automation. I would always go for the Fabric CI/CD Python library in regards to deploying my Fabric items. And then again, as I started out saying, design everything you do with automation in mind. Also in regards to how you name things, how you build things, always kind of like try to cater for that. Yes. And implement a metadata-driven framework. So again, utilize the power, for example, of the Fabric SQL database in order to have a metadata repository where you store, okay, which objects and which columns do I need to extract from this specific source system. Do this dimension load in slowly changing dimension type 1 or 2 or 3 or whatever. So try to use metadata for kind of like building those scalable solutions. And then Stay curious, try to get inspired what others build. There are a lot of things out on both GitHub and blog posts as well on different approaches. So as I said, there is no silver bullet. There's no single point of truth. So in regards to this, try to figure out what suits best in regards to number of workspaces, how you structure your repos, how you do collaboration on your feature developments, and so on and so forth. Go ahead and download my presentation. And also find all the demos and Python scripts, pipelines, and so on and so forth on my GitHub repo. And then questions.
API,
And what I will do is,
so there's 11 questions in, if that's all right.
Cool. I will just, let me see, I will just do like this. So.
Can you see the questions so you can see the 11
yes,
and then the questions? And you can just, or do you want me to read them out to you?
Would you sometimes split out prepare, model, and present even further per area data product? Actually, I haven't done any solutions where I have split prepare even further. In regards to model, definitely. So because you might have different domains or areas that needs a different isolation of your semantic models. So definitely in regards to that, I would say yes for your modeling part. For your modeling part, so your semantic models and report and so on. Of course, that would make sense. Actually, I haven't done it in regards to the prepare, so having prepare sales, as you state, for that matter. But it could easily be done using a template approach or recipe approach to have that up and running. Also curious to I think that we answered that one. How can we implement source control for lakehouse SQL views or other objects like security schema? Yes. So as for the Fabric CLI/CD Python library, for example, if I can start with that one, when it deploys, for example, a SQL database, it will only deploy the shell. So what I usually do in regards to working with the metadata database, for example, is that I have a SQL project that will kind of like work as the source of truth. So that will be deployed by building it with MS Build to create a DAG pack and then deploy that using kind of like normal standard because it is a Azure SQL database behind. As for the Lakehouse SQL views, I will have to come up short on that one. I really don't have an answer for that. Sorry about that one. Is there a reason why you? Yes. So actually, in regards to why, the question is, why do I use my approach, kind of like the recipe approach, instead of using Terraform? I am not a Terraform guy. I am a developer, so my initial approach was kind of like do what I usually do. So I used Python for that matter, and then I turned to the Fabric CLI, also because I like the Fabric CLI interface. When it comes to Terraform, Terraform HashiCorp was acquired by, or the guys who run Terraform was acquired by IBM. So they also changed things in regards to their licensing. And I do know that there are maybe obstacles in regards to turning towards that. Also, Terraform is not by default anymore installed on your Azure DevOps agents. So you need to install that as well. Of course, you also need to install the Fabric CLI. But from my point of view, there was a learning curve to me in regards to Terraform. So that was why I kind of like decided to go that way. Also due to the fact that I started out with the automation process and the Fabric REST APIs prior to us even having the possibility to use Terraform. So that is the why. But there's no kind of like rights or wrong in regards to that. And I also need to kind of like brush up on the Terraform and see how that will work. I have two 2 UAT, 2 pre-pod, and 1 production room in mind because we can only attach 1 workspace to a deployment pipeline. I cannot attach prod to 2. Yeah, okay. So that again, it's in regards to a setup where you have kind of like differences between the environments, and as stated again, Fabric deployment pipelines are limited. I guess that Gautam is referring to Fabric deployment pipelines. So and when we're working with scripts and Python and so on and so forth, and the Fabric CI/CD, we have a lot of different other possibilities. So I haven't handled the same case, but I will definitely try to look into it and maybe give you a comment later on that one. Definitely, Katrine, are there scenarios where you would not use this approach, where it would be too big, complex, or do you see it working for any? I actually see it working for any size, any company. We have. I used to work with Today, which is a pan-Nordic consultancy company, and where I also kind of like was the author behind the whole CI/CD flow and automated setup. And even though that it was a minor, really small solution, we still did it the same way. We might limit the number of workspaces or layers that were needed, but we still kind of like set it up because it's so easy. You saw it took 5 minutes to run the pipeline, and we have this template repository that we can use. So we can easily define kind of like how much we need to set up. And the good thing is that if we do something wrong, maybe we do a wrong naming convention, there is actually also a pipeline you can run that will tear it all down again, and then you can set it up again. So it is pretty easy. If you make a mistake, just tear it down, run it up again. Having to do that manually, I would never ever go with ClickUps for that matter. So definitely yes. When multiple developers are working on different features simultaneously, it's advisable to create dedicated developer workspaces. Yes, it is. My approach is always, usually when you work on a feature, it's a single developer feature. It might be that I need to create a new measure on a semantic model. We won't be 2 or 3 or multiple developers on that specific measure, on that specific feature. There might be cases where you work together, multiple developers on a feature. Then you would have to work on the same feature workspace. So it is not a developer-specific workspace. From my point of view, I see it as a feature-specific workspace, because you can easily work multiple. But anyway, I think it's more common to split it out so that you kind of like multiple people don't work on the same feature. That's, at least from my point of view and my experience, the most common way. But you can easily set it up so the fact that it automatically assigns multiple users to a specific feature workspace when it's being set up. Okay, should we just grab the last one? Can you get the feature workspace back quickly, for example, if a bug gets discovered? No, you cannot. Or actually, you can, because you can see you can restore workspaces that have been deleted from the admin portal. But from my point of view, if something has been reviewed, approved, and been merged into main, then you create a bug fix feature for that specific fix. You don't go back because if you move it in, the branch is deleted. Yes, that can be restored. The workspace is deleted. Yes, that can be restored. But the right approach would actually be to make a bug fix if it's something that has been approved and has been moved in, due to the fact that typically you squash those commits that was made to the feature branch before pushing it into main. Okay, a little bit over time. Apologize for that.
You're all good.
But
It was
anyway,
a great session.
I'll try to see if I can in some way answer some of these questions. Maybe we can take that afterwards.
Perfect. Yeah. So perfect. So on behalf of the ESPC community, I'd like to extend a big thank you to you again, Pierre, for taking time out to carry this webinar. I really appreciate it. So that's the end of today's webinar. You can find this webinar and more at sharepointeurope.com/resource center. Thanks again for all of you for joining us today. I hope you join us again soon. Take care.